are produced that weaken the metal. As a rift is produced in the bottle, the liquid butane is overheated, nucleates, and finally results in a boiling liquid expanded vapor explosion. Here we have a butane bottle with EXCO control in an extreme case. The safety valve is sealed off with steel bars that have been bolted down to its gas tap. When pressure is increased due to overheating, the soldering is affected and the gas escapes. The enormous heat generated by 20 liters of petrol and 25 liters of diesel oil increases the pressure yet again, producing the expulsion of the mixture, but not a boiling liquid expanded vapor explosion. Since the contact surface of the fuel inside the bottle with the aluminium is increased by 3,000%, thanks to the effect of the netting, the nucleating effect of the fuel is avoided, and thus a boiling liquid expanded vapor explosion. The crack, seal, and deformation of the bottle can be observed. This case is the same as the previous one, but without EXCO control. After 2 minutes, the bottle cracks. Part of the gas escapes that refrigerated the walls. The material is weakened. A crack is produced due to the enormous pressure, and the boiling liquid violently evaporates, nucleation, and it comes into contact with oxygen, producing a boiling liquid expanded vapor explosion. Parts of the bottle could be found 200 meters away. The tray was completely destroyed. The energy freed in the violent explosion could completely destroy an apartment where the bottle was situated, together with 4 surrounding apartments. Shots made against bottles containing gas only produce a hole through which the gas escapes, making the valve itself a safety valve. The gas bottles are filled with EXCO control by a machine created for this effect through an existing orifice before placing the gas tap. Here we can see a chain reaction explosion in a city gas pipe system. This accident could have been prevented with EXCO control, as we will now see. We are now accumulating gas. If an accident takes place in the pipe, the wave effect produced by the explosion would be transmitted only to the point where the protection has been set up. The flames are stopped at that point. We will see that upon igniting the opposite end of the pipe, an explosion takes place, refuting the theory that pipes don't explode. The reaction speed is exponential, making the pressure increase inside the city gas piping system in a short period of time, and then producing the explosion, in this case, the expulsion of the lid. Here we have a protection system that prevents the advance of the waves produced by gas combustion, avoiding the spread of fire from the protected zones and preventing a chain reaction throughout the pipe system down to the main tank, and thus avoiding an explosion. If an accident were to occur, we would only have to repair the stretch existing between 2 protector systems. Fields of application: gas tanks in developments, plants and butane gas bottles. Refineries and chemical plants. Aviation. Military vehicles, aircraft and vessels. Helicopters.
Every motor-powered movement.
Terrorism and public transport. Vehicles and tanks. Gas pipelines. Oil tankers and fuel transport trains, etc.